Let's talk next about local or relative extreme values. In the last video, we talked about absolute or global extreme values. This time, we're going to look on a bit smaller scale. So we're going to talk about local maximum value and local minimum value as definitions. We're going to describe what we mean by the term relative extrema and then an absolute extremum. There are no rules or theorems in this section. So let's get started then with a graph and a bit of a description. This figure below is a graph with 5 points. So 1, 2, 3, 4, and 5. And it has extreme values on the domain that's closed from A to B. This function's absolute minimum occurs at A. Remember from the first video, an absolute minimum is the smallest value of the function, and that's over here. And that makes sense. There are no other y values that are lower than or have a smaller value than the y value here. In fact, we could even kind of draw a dotted line across and see that that is the smallest value. It occurs at A, even though at E, the function's value is smaller than at any other point nearby. So we want to point out that there's another small value of this function. It occurs at the x value E, and that one's going to be called a local minimum. We'll get into a bigger definition of that in just a moment. This curve rises to the left, it falls to the right around C, and that makes f of C a maximum locally. So here we are talking about maxes and mins that are not absolute. They are high points or low points. They are, I like to call them tops of hills and bottoms of valleys in the function's graph, but they may not be the tallest or the highest peak of a hill or the lowest point in a valley. They're just higher or lower than all the points around them. And then this function attains its absolute maximum at the interior point D because there are no other points on this graph that are higher than that y value. So this graph is a nice way to look at the difference between local and absolute minimums and maximums. Absolutes are usually using the article the. It's the smallest point, it's the highest point, the absolute minimum, the absolute maximum. A local maximum, a local minimum are points on the graph that are just happen to be higher or lower than all the other points in the immediate vicinity. They're just bigger or smaller than all the points nearby. So here's our formal definition. Let's let C be an interior point of the domain of a function f. Then f of C, remember that's a y value again, is a local maximum value at C if and only if f of x is less than or equal to f of C for all x in some open interval containing C. So this means all of the y values are less than or equal to, which means they're all smaller than this one, the local max. So that makes sense. It's a maximum value because all the other y values around it are smaller. And it just happens to be that this occurs in some open interval. So it might be a large space, it might be a small space, but as long as there's some defined space where you have a y value bigger than all the others, it's a local maximum. And the same goes for the local minimum. There's a local minimum value at C if and only if the f of x values or those y values are greater than or equal to f of C. That's your local min for all x in some open interval containing C. So local maximums and minimums, aka local extrema, are also sometimes called relative extrema. So we use the term local and relative to mean essentially the same thing here. They are y values that are larger than or smaller than y values nearby. An absolute extremum is also a local extremum. That's interesting. So just because you are the highest or the smallest point, you're also a local one too, because you are higher than or smaller than all of the y values nearby. So any list of local extrema will also include the absolute extrema if there are any to be found.